Hi everyone, today I'll be doing the mechanics quiz for term 1 week 7. Now, we'll start with question 1, a possible equation of motion of a particle moving in the positive direction, so this is very important, at constant speed, this is also very important, is, now, if you notice here, they gave us all position equations, right? They're all in terms of x, right? And x, as you know, x of t, if you were to describe the position as a function of time, which is essentially what they did here, right? Is the position. Okay, now, how do we get the velocity, v of t, from this? All we're gonna have to do is we're gonna derive the x of t equation that we're given, right? So, let's derive this, right? You should all know how to derive. Now, 4t squared is gonna derive to 8t plus t, this is gonna differentiate to 1. Now, this is definitely not constant. Why? Because you have a variable, you have t, you have time, right? So the velocity, this is equal to v of t, right? This is equal to the velocity of this particle. Now, say it's v of 1. Say it, you're measuring at the first second. The first second, 8 times 1 is 8, plus 1, 9. So at v of 1, at 1 second, it's 9 meters per second, let's say. Now, at t equals 2, 8 times 2, 16. 16 plus 1, 17. So it changed, right? It's not a constant speed. This is wrong because it changed from 9 to 17. Now, negative 3t minus 3. This is negative 3t is going to differentiate to negative 3. That's it. And then minus 3 differentiates a constant, so it's 0. This is equal to the velocity time or the velocity function of this particle, right? Now, while this is a constant speed, right? At t equals 1, it's going to be negative 3. T equals 2, negative 3. T equals 50 million, it's going to be negative 3. What it is not, though, is not, it's not positive, right? Because my velocity here, my velocity is less than 0, right? Look, it's not moving in the positive direction. It's moving in the negative direction. So this is wrong, right? Now, x equals 7t squared minus 4. You should immediately know this is wrong. But why? Because when you differentiate this, you're going to get 14t, right? Now, since we have t, that means that this is going to change. So like this is equal to v of t. Now, at t equals 1, it's going to be 14. T equals 2, it's going to be 28. So as you can see, there is a change. Now, x equals t minus 1. This will differentiate to 1, right? This differentiates to 1 because it's going to be t to the power of 1. Differentiate, it's going to be 1t0, so it's going to be 1. 1 is a constant. This is correct. Done. That's it. Because as you can see, it's a constant. And not only that, it's a positive constant. So v of t, right? This is equal to v of t. v of t is greater than 0. So v is bigger than 0, making it moving in the positive direction. This one, if you were to differentiate it, right, if you were to differentiate negative 6t plus 1, you're going to get negative 6. Negative 6 is a constant moving in the negative direction, so it's not correct. Question 2. At t equals 0, a spring gun is used to eject a ball vertically upwards at 12 meters per second from the top of a tower. A. The ball reaches a maximum height B and falls back to the ground. C. Neglect air resistance and take G as 10 meters per second squared. Okay. If they want the height of the tower, if it hits the ground at t equals 6 seconds. Now, free fall, right? Free fall, the equations are exactly the same as UARM. And you should know the UARM equations. Now, for this one, instead of delta x, however, right? Instead of delta x, you're going to have delta y. And instead of x, you have y, right? Because you're only moving upwards and downwards. You're not moving left or right or whatever. Okay, so in our case here, we're going to take the equation delta y equals half a t squared plus v0t. Why? Because why delta y? Why are we taking delta y? It's because delta y is initially point A to point C, right? This is the change. This is the displacement in the y, right? And if you notice, from A to C, what is it? It's the height of the tower, right? This is the height of my tower, right? So delta y is going to equal to, now instead of a, what are we going to use a as? We're going to use a as g, negative g. Why not g? Just negative g. Because in free fall, you have this rule. You're going to take the positive direction of the y-axis, because this is, you're traveling along the y-axis, right? Now, what are you taking positive and what are you taking negative? So here, they said the ball was thrown vertically upwards at the start, right? This is my v0, by the way. I'm just marking it from now. This is v0, right? Now, look, it got thrown upwards first, then it got thrown downwards. So the initial direction of motion is upwards. And that's what I'm taking the y-axis as. The positive y-axis. The positive y-axis is when it's thrown in the direction of the motion. So, for example, if I dropped a ball directly down like this, my y-axis would actually be positive going down, right? So this would be y here, this would be negative y. However, if I throw it up, then my y-axis is gonna be positive upwards, okay? It's a bit tricky, but it's essentially the initial direction of motion, that's your positive y-axis. Now, here, they said they threw it directly upwards, right? So, when it got thrown directly upwards, as you know, gravity always acts downwards. Yes, it's common sense. But however, I'm throwing it up. That means I'm going against the work of gravity. So it's not g, it's negative g in my case. So it's gonna be half of negative g times t squared plus v0t. Okay, I have everything given to me already, so I don't need to worry about anything. Half times negative 10, right? Because they told me take g as 10 meters per second squared into t equals 6, so we're going to take 6 squared, 36, plus, v0t. Now, v0, as I said, is 12 meters per second, it's given to me, and t is 6. Okay, doing this on a calculator will give you 0.5 into negative 10 into 36 plus 12 into 6. Gives you negative 108. Sorry, negative 108. Now, okay, you might be saying, the answer is 108. How did you get negative 108? That is correct. Again, y, remember, this is the displacement. This is delta y. This is the change in y. I started up. This is my origin, by the way. A is my origin, right? Because it's another rule of free fall. The origin is the initial point of when you threw it. Okay, whenever you threw the object, that's your origin. Okay, so I threw it at point A. Okay, this is my origin. A is my origin. And it landed at point Z. How much did it go? It went down by 108 meters, right? And C is the ground, right? So this is the height, right? 108 meters is the difference between the origin and the ground. So that means 108 meters is the height of my building. The negative just means I went down 108 meters, not up. Just clarifying that. Okay, so this is my answer. Done. Moving on to question 3. Okay, question 3 is taking a long time. When it stops loading, I'll pause the video. Okay, so question 3. Very, very, very easy. What's the acceleration between 0 and 2 seconds? Now, 0 and 2 seconds. You can see during this interval, it travels in what? A straight line. So when it's a straight line, right? Straight line, that means it's on a VT graph. That means what? V is increasing or decreasing. Let's say V is changing, just so we can mention both. V is changing at a constant rate. What does this mean? Essentially, what is the rate of change of velocity? That's acceleration. That means acceleration is constant. Right? Because if V is changing at a constant rate and acceleration is the rate of change of velocity, what does that mean? Acceleration is constant. And what does that mean? That means we're in UARM at this phase. Okay? That means UARM. So basically the summary of all of this, whenever you see a straight line on VT graph, just skip all of this reasoning and go directly to the conclusion that first of all, A is constant and it's UARM. You don't need to say all of this. This is just to explain what is actually going on. Okay, these are the important takeaways. That when you see a straight line on VT graph, you should know that you're at a constant acceleration and you have UARM, which is essentially the same thing. UARM means you have a constant acceleration. Now, that means that if I find the slope of this graph, or this line, because it's not the whole graph, if I find the slope of this line, that slope is the acceleration, right? Acceleration is the slope. Okay, so you know the acceleration formula, it's delta V over delta T. So let's take delta V over delta T. Now, they said the interval is 2 and 0. So 0 and 2. Whenever, what's the velocity at 2? It's, you can trace the graph, it's 4, right? What's the velocity at 0? 0. Now 2 minus 0, 4 over 2 is gonna give me 2 meters per second squared. That's my answer. Okay, moving on. What's the net displacement of the object? You can see here it's a trapezoid, right? And this is the graph here, makes a trapezoidal shape. Okay, now what is the displacement on a VT graph? It's the area under the graph, right? So it's the area covered by this trapezoid, okay? So x, which is the distance traveled, is just gonna be the area under VT graph. Okay, and how do you find it since it's a trapezoid? You use the formula for the area of the trapezoid, which is base 1 plus base 2 over 2 multiplied by the height, right? So now our formula is very, very easy and we can easily calculate this, right? So base 1 is from 0 to 10, which is 10, plus base 2 is from 2, look, it's from 2 to 6. It's from 2 to 6. 6 minus 2, so this is 4 meters long, right? We're measuring not 4 meters, but this is 4 units long, let's say, right? Because we're measuring the length of the bases, and that's what this is actually is, right? So it's basically, essentially, thinking about it, right? It's 10 minus 0, so our first base is 10 units long, and it's from 2 to 6, 6 minus 2, 4 units long, right? Now multiplied by the height, if you can trace it here, it's 4, so times 4. Okay, do this on a calculator or mentally. 10 plus 4 is 14 over 2 is 7. 7 times 4 is 28. So 28 meters. Done. That is my answer. Okay, question 4. Okay, now for question 4, we have a cyclist speeds up from 5 meters per second to 25 meters per second in 10 seconds. Then he travels at 25 meters per second for another 10 seconds. What is the total distance? Okay, this is a lot of mumbo jumbo that I can summarize in a graph, right? So let me take a VT graph. VT. Okay, so he started off at 5 seconds. Then he moved to 25 seconds. So 5 and 25. Okay, now this here, this was 0, t equals 0. And then he said they reached a 25 meters per second mark at 10 seconds. Okay, then he travels at this 25 meters per second constant for another 10 seconds. So what's 10 plus 10? 20. What is the total distance? Now, you might think, okay, find the area under the graph. You can, but it's very, very, very annoying. And I don't think it actually would work fully. Because if you find this, right, let me take an example. Let me just show you as an example. Finding this, okay, you're gonna take this, then this, which gives you 5, 0, sorry, this is a triangle, right? So it's gonna be half times the base times the height. The height is from 25 to 5, so it's gonna be 20. Half times the base is 10, and the height is 20. Okay, this gives you 100. Plus, and then you're gonna take this as a rectangle. Okay, you're gonna take this as a rectangle. So you're gonna do 20 times, or 10, sorry, 10 times 20. This will give you 300, right? 300 is not the answer, it's 400. So you're not accounting for another 100 meters. So I wouldn't use the graph for questions like this. You can, I'm pretty sure at least you can, but it's a bit harder to calculate using it. Anyway, so let's calculate it using equations, and the equations are very, very simple, right? So here, what we can actually see from the graph is actually still very, very useful. Our first phase, we can split this up into 2 phases, the first phase and then the second phase. Right? The first phase is the straight line, and then the second phase is the flat horizontal line. At phase 1, it's UARM, because what did we say? If it's a straight line, it's a constant acceleration, which means UARM. 2, it's URM, right? What is URM? When velocity is constant, no change. And that's what we can observe in the second phase. Okay, now, so we're gonna have to use the corresponding equations. Now to find displacement in the first one, we're gonna use x equals half a t squared plus v0t. Okay, that's what we have given to us. Perfect. Now, I'm pretty sure there is actually a simpler formula for this, but it's fine. Okay, not to worry though, it's fine. What we can do now is solve using this equation, right? Now, how do we do this? It is actually very easy. So, half times the acceleration. Now, the acceleration is going to be 25 minus 5 over 10, right? Because it's delta V over delta T. Delta T is 10 seconds. Delta V is 25 minus 5. So, it's going to be 20 over 10, right? 20 over 10 is just 2 meters per second, right? So, it's going to be half, do it with me on a calculator, half times A is 2, times t squared, t is 10, so 10 squared, plus v0t, v0 is 5, right? This is our initial velocity here. This is the initial velocity, v0. v0 times time, which is 10, gives you 150 meters. So x here is equal to 150 meters. Okay, now we found the first phase. Phase 1, x equals 150 meters. Right? Now, phase 2, okay, phase 2, it's URM. So we're gonna use the URM equation, x equals vt plus x0. What are we using as x0? We're actually gonna use this as x0, right? Because this is the total distance traveled. This is the initial distance traveled in the first phase, right? But we're now at the start of the second phase. So we're taking this because this is the initial displacement, initial position. Initial position is the position at the start of this phase, right? It's at the start of phase 2. What's the position? It's going to be 150, right? So x is equal to vt. So he said 25 meters per second. So 25 is v times another 10 seconds. So he said 10 seconds. Now that's vt plus x0 is 150. It gives me 400 meters, and that is my correct answer. Done. Moving on to question 5. Okay, same concept. A bus starts from rest at point A. So let's pull out my graph from now, just to help me explain what's actually going on. And if you ever don't understand what's going on in a question, it's just words, make a graph. It will clarify what's going on for you, right? Starts from rest at point A, so we know he's starting from this area here, the origin, and accelerates at 2 meters per second for 10 seconds. We don't know the final velocity. It then runs at a constant speed for 30 seconds, so like this, 40 now, because 10 plus 30 is 40, and then slows down until it stops. So it's something like this. Okay, now you can see you have 3 phases: phase 1, phase 2, phase 3. Now, phase 1 is UARM, as you can see. Phase 2 is URM, and phase 3 is also UARM, right? Because it's a straight line on the velocity graph. Okay, now let's calculate for each phase. Okay, and then you can just find the area. Actually, I will solve using 2 methods here. This is where I can actually solve using 2 methods, because it's a trapezoid under this graph, and it's very, very easy. All I have to do is find v, find the final velocity during this first phase, right? So I have to find this v, right? And then I can find the area under this graph by finding using the trapezoid rule. Now, okay, so it's a straight line, right? It's a straight line. That means my acceleration is constant. And they told me in phase 1, right, it starts from rest and accelerates at 2 meters per second squared for 10 seconds. How am I going to find this velocity here? I'm very easily going to use my acceleration formula, which is delta v over delta t, right? Now, acceleration is equal to, my final velocity is this v, right? I called it v. And my initial velocity is 0. Why? Because it starts from rest. So v minus 0 over t is 10. Delta t is 10 seconds, right? That's given to me. Now, okay, what's my a? My a is 2 meters per second. So I'm going to swap a with 2. Multiply. Since this is just going to be v minus 0, we're going to write v. 2 times 10. V is equal to 2 times 10, which is 20 meters per second. So now I can swap this with 20. Okay, now this is very, very, very easy, right? Because I just have to apply the rule, right? So distance, which is x, is gonna equal to here this time. Actually, we can't find this. We can't find this time also, because we need this time, right? Now to find this time, we need using phase 3. Now, we know in phase 3, it slows down at negative 4 meters per second squared until it stops at point B, right? So, if it slows down at negative 4 meters per second squared until it stops at point B, I have my acceleration, okay? I have my initial velocity here. This is the point of initial velocity, which is 20, right? And my final velocity is 0. Why? Because it stops at point B. So this is its final velocity, 0. And it was initially traveling at this point, right? This is where I start my phase 3. Here, I'm going to call this point A. or actually I'm gonna call it point F. I don't know, I feel like point F. At F, I start my phase 3, right? So initially, what was I moving at point F? 20 meters per second, right? So my, remember the formula is Vf minus Vi over Tf minus Ti, whatever, right? Now, Vf is 0 because as I said, it stopped. Vi is 20 over Tf minus Ti. You know the time, it's fine. The time is what we actually want to find. Never mind. So it doesn't even matter. Okay. Now, negative 4t is equal to negative 20. Right? I just multiplied. I took this up. So t will equal to 5 seconds. Right? So this car or this bus stops after 5 seconds after this phase of motion. So what's 40 plus 5? 45. Right? So now I can apply my trapezoid rule. X is equal to base 1, which is 45, plus base 2, which is 40 minus 10, which is 30, over 2 times 20. This gives me, on a calculator, 45 plus 30 over 2, 45 plus 30 over 2 times 20, 750 meters, which as you can see is indeed my right answer. Now, if you didn't understand, watch this, keep watching. If you did understand, skip ahead, right? Skip ahead in the video. I don't want you guys to get confused because I'm gonna use the equations now. Because if you didn't understand the graph, يعني just as a backup method. But I don't want to confuse you guys. So if you didn't, if you understood the graph, just go on to the next question. Okay. If you didn't understand, keep watching. Now, here, okay. A bus starts, again, I'm going to take it 3 phases, like I did with the graph. I'm going to take it in 3 phases. A bus starts from rest at point A and accelerates at 2 meters per second at 10 seconds. I know, since I have an acceleration, and since it says it's a constant acceleration, I know this phase is UARM, right? Because I have an acceleration, and they told me it's accelerating at this rate. It's a constant acceleration, it's very obvious, right? It's told in the question essentially. So phase 1 is UARM, right? Because it says it's accelerating at 2 meters per second for 10 seconds. That literally means it's a constant rate of acceleration. Okay? Now, it then runs at a constant speed for 30 seconds. So, if it says constant speed, velocity is a constant. What does this mean? It means phase 2 is URM. Okay? Now, it says it slows down at negative 4 meters per second squared until it stops. That means phase 3 is also UARM. Okay, now that we've identified our phases, we can use our equations of motion, right? So for UARM, we're gonna use x is equal to half at squared plus v0t plus x0. Okay, now since it starts from rest, initial velocity is 0, right? So this is gone to 0. And then since it starts from rest, it's going to be 0 meters, so this is gone too. I can remove these two, right? So this is my equation from rest. Okay, now this is very, very easy to apply. X is going to be equal to half times 2, because acceleration here, A is equal to 2. Then t squared is 10, t is 10. So what's t squared? 10 times 10 is 100. Now, doing this is going to give me, the half will cancel with the 2, so 100 meters for phase 1. Right, I'm going to call this x1. Now, this was for x1. x2 equals the URM motion, right? So, we're going to follow the formula x equals vt plus x0. Okay, so v is not something we know, right? But t is something we know. So we're going to write 30v plus x0. x0, we're going to use x1, right? Because remember, this is where it picked up. Phase 2, the moment where it changed to phase 2, it's already 100 meters in, right? So it's going to be this. Now, how are we going to find v? Similar to the way we found it in the graph. It's the same exact way. So acceleration is delta v over delta t, right? That means that my acceleration, which is 2 meters per second, which runs along 10 seconds, is from v minus 0, right? Because it started from rest, right? So I'm going to multiply. Sorry, where am I? I'm going to multiply. Oh my God. I'm going to multiply 2 times 10 is 20 equals v. So v equals to 20, right? I'm going to change this to to 20. Now, x2 is equal to 30 times 20, 30 times 20 is 600, plus 100 is 700 meters. Okay, so this is where we are at so far. Now, we have phase 3. For phase 3, it's very, very easy. For phase 3, it's UARM again, right? So we're going to use x equals half AT squared plus V0t plus x0. Right? Because this time we actually have an initial displacement. So x is equal to half times a is given, -4. T is not. T is something we have to calculate. Now, how do you find T? Again, we're using A equals delta V over delta T. So A is 4, -4. Delta V, so it said it's until it stops, right? So that means VF, V final is 0. So 0 minus, and then you know this at as you saw on the graph, I changed my motion at point F where it was traveling at 20 meters per second, right? So it's minus 20 for initial. Now, time is something we don't know. -4t is equal to -20, so t is equal to 5. Okay, so we're gonna substitute 5 into my equation. So -4 into 5 squared, which is 25, plus v0t. V0 is 20. 20 into 5 plus x0. X0, we're using the x2, right? Because at phase 3, at x3, we're already 700 meters in. So we're doing this. Now, 0.5 times -4 times 25 plus 20 times 5 plus 700 gives me x3 to be 750 meters. And that's my final answer. Moving on to question 6. Okay, question 6. The motion of a car consists of 3 phases as shown in the table below. The car accelerates from to rest. Okay, blah, blah, blah. We have the 3 phases. The duration of phase 1 of the car's motion. Now, here you have acceleration, okay, and it says from rest at 3 meters per second until it reaches the speed of 18 meters per second. So you can see it's a constant acceleration. That means what? U, A, or M. Done. Okay, that means we can apply the acceleration formula because it's a constant, right? So it's A equals delta V over delta T, right? So A is equal to, A is 3. 3 is equal to delta V, which we have it starts from rest, so V initial is equal to 0, and VF, the final velocity, is equal to 18. So it's 18 minus 0 over T. Right, so 3t is equal to 18 when you rearrange the 4 equations. So divide it will give you 6 seconds. That's the first answer. Now, the distance traveled in phase 1 is 54 meters. Why? Because you can apply the formula x is equal to half at squared. Why? Because it started from rest. So you don't need v0t plus x0. So x is equal to half times 3 times, as we found the t is 6, so it's going to be 3 times 36. Now, doing this on your calculator, 0.5 times 3 times 36, 54 meters. And that is the correct answer. So that's what we have so far. The total duration of the car's motion. Okay, so we know here that this part is 6 seconds. And we know here that this part is 9 seconds. Right, so we just need to find this here. Now we have that it's a constant speed of 18 meters per second. What does this mean? URM, right? Because it's constant speed. So we can apply x equals VT plus x0. Now we have x0, we have V, and we have T, or we want T. We have x. So actually, wait, no, we don't need this. We can just say delta x, right? Because we move this to the other side, it'll be x minus x0. Delta x, which is what we have, right? It moves 360 meters. So that's the change in x, 360, is equal to vt, right? This is just another way of writing the formula. Because again, I took x0 to the other side, and you know that delta x is equal to x minus x0, which is the initial. So delta x is equal to vt. So delta x, which is 360. So 360 is equal to 18t. Now, to find t, you divide 360 by 18. It gives you t equals to 20. Now, add 20 plus 6 plus 9. You get 35 seconds. Done. Okay. The total distance traveled by the car. Okay. So, you have 3 phases. As we identified, this one's UARM. We identified this one as URM, and we identified this one. We didn't identify this one, but this one you see decelerates immediately. You think of UARM. Okay, now you can either graph this or you can solve it mathematically, which I will do in both ways. So first of all, the graph, right? So you initially started from rest and you accelerated at 3 meters per second until it reaches the speed of 80 meters per second, right? And we calculated this time to be 6 seconds. Now you travel at a constant speed of 18 meters per second. Sorry, where did this line come from? So travel at a constant 18 meters per second, right? For how long was this? I believe it was 20. This was 20 seconds. So this part here is 26. Right? Now, you decelerate in the last, how much is this? 9 seconds. So it's until 35. This is how long your graph of motion is. Now, the distance is gonna be the area of the trapezium. So it's gonna be x is equal to, x is equal to, what's the first base? The first base is 35, plus the second base is 26 minus 6, which is 20 over 2 times 18. Do this on your calculator. 35 plus 20 over 2 times 18 gives you 495, which is indeed our answer. Now, if you didn't understand, please stay. I will explain using calculation. But if you understood, please skip ahead because I'm going to explain again using equations. And I don't want you to get confused. If you want to, you should. I recommend you to stay because it will teach you how to work with equations. But if you're confident enough with the equations and you're just lazy and you want to hurry up because yalla, yani, I want to sleep or I want to watch TikTok or whatever, go ahead and just skip. In phase 1, it's UARM, right? And we know it took 6 seconds, okay? And the distance traveled, we can find it, right? The distance traveled is going to be x equals half AT squared, right? So actually we found it also. We found it in double I. 6 seconds and 54 meters, right? We found it, as I said, we found it in double I, so I don't need to re-explain it. You can rewatch the explanation. Basically, I used the formula x equals half AT squared. Okay, now the car moves a further 360 meters. So we have the distance given here for us. We don't need to calculate it in phase 2. Now, here for this one, we can find the acceleration, right? Because this is also UARM, right? So we're gonna apply the x equals half AT squared plus v0t plus x0. But actually, we don't even need to apply it. I'm gonna try it in a different method. See if it works for you guys. So let's find the acceleration. You need the acceleration, right? You know that the initial, because this point here, this is the point where it changed into phase 3. It was initially traveling at 18 meters per second. And it stops, it decelerates to rest. So V0 is 18 and Vf is 0. So it's going to be 0 minus 18 over 9. This gives me negative 2 meters per second. Now, I'm going to apply the time-independent equation because say I don't want to find time, I'm too lazy. V squared minus U squared equals 2A delta X. Okay, this is one of the equations and it's very, very important. You know V squared is 18. So 18 squared, or sorry, V is 18, right? Or sorry, V is 0, right? Because you decelerated to rest, right? So you stopped at rest. This is your final velocity. So it's going to be 0 squared minus U squared is, U is 18. U is V0. So let me rewrite this. This is V0, right? V0 is 18, so it's minus 18 squared equals 2 times negative 2 times delta x, which is what we want to find. Okay, so do this on your calculator, preferably using your equation solver, because if you're not comfortable taking it to the other side and whatever. Negative 18 squared equals negative 4x. So this will give you delta x equals 81 meters, right? So that means in this phase, we traveled 81 meters, okay? Now, you can add up, of course, you can use the formula x equals half AT squared plus V0t plus x0, right? You can use this. And this will actually give you the displacement in one step. Why? Because x0 will be 54 plus 360, right? Because x0 you'll be already By calculating for this phase, you'll already be, how much is 360 plus 54? 360 plus 54. You'll already be 414 meters in, right? You'll already be 414 meters in when you reach phase 3, right? So this is your initial displacement. Now, we didn't use this, but you always can. I'm not gonna, I already found it, so I'm not gonna solve it using this method. 54, I'm gonna add all of these up now. 54 plus 360 plus 81 gives me 495 meters. I'm done. Question 7. Okay, this is very, very, very easy. Like, it's even easier than any other question we've encountered this quiz. Now, the average acceleration during the first 5 seconds. So this is t equals 0, and then t equals 5 is here, right? Average acceleration is the slope of the secant. Okay, the secant is the thing joining two lines, right? So this is 2 and this is -1. You can tell this is 2 meters per second and this is -1. So you're gonna do v final minus v initial, -1 minus 2, right? -1 is my final, my initial is 2. And that's v0, it's the final minus the initial. So -1 minus 2 over the time it took, which is 5. Now, do this on your calculator. -1 minus 2 over 5. You shouldn't be doing this on your calculator, but whatever. -3 over 5, which is -0.6 meter per second squared. Okay. Question 8. Drag and drop the correct answer, blah, blah, blah. Okay, now, a bicycle speeds up in the positive direction. If it's speeding up in the positive direction, acceleration is obviously going to be positive. This doesn't even need explanation. If a bicycle is slowing down in the negative direction, right? Like, you're moving in the positive direction, but you're slowly moving less in the positive direction. Like, look, if this is your velocity, look, you're moving less. It means your acceleration is decreasing, right? Because you're moving less quickly, okay? Even like, think about it, right? You're moving on a bicycle, right, in a certain direction. You're slamming the brakes, right? Say you're about to bump into someone while you're in your path. You're gonna slam the brakes, right, and that's gonna decelerate, right? You're gonna decelerate. Now, if a bicycle is speeding up in the negative direction, that means the magnitude of the acceleration is increasing. The magnitude, okay? However, if you include the sign, you're still moving in the negative direction, right? You're speeding up in the negative direction. Doesn't matter if you're moving in the negative direction or not. You're speeding up in the negative direction. So if you think about it, right, you're going back like this, then you're going even more back like this and more back like this, but the positive direction is this way, right? So obviously you are moving in the negative direction, and your acceleration is less than 0. Your acceleration is negative, right? Because you're speeding up in the negative direction. You're actually becoming technically, your acceleration is becoming smaller. So if you have 5 meters per second squared here, right? You're gonna have -10 and then -15, right? Your acceleration is becoming more and more negative. That's why this is the answer. And a bicycle slows down in the negative direction. So say you had like this, and then like this, and then like this. You're moving towards the positive side, if you think about it, right? Like, your acceleration is moving towards the positive side because you're slowing down in the negative direction, right? So like, you're moving to, like, your acceleration, think of it as an arrow, right? It was initially like this, but then it's slowing down in the negative direction. So it's going like this, and this is the positive direction, right? So your acceleration is greater than 0. Okay, this was this question solved. Very nice and very easy. Okay, question 9. What characteristic of the UARM causes the VT graph to be linear? As we've been saying for the past 20 million questions, if it's a linear line on a VT graph, it's UARM. Why? Because the acceleration is constant. The acceleration is never changing. It's the slope of this graph. And you know, in a linear line, y equals mx plus b, right? M is staying the same. M is the slope, and it stays the same, right? So the acceleration here never changes. This and the slope will never change. That's what gives it a linear VT graph. Okay, the acceleration is constant. It's a very, very easy question, and we've explained this concept. Question 10. Okay, question 1 is not very hard. Now, they're telling you this is the velocity time graph of an object. In what phase is acceleration the highest? Now, this is a VT graph. You know that the acceleration on a certain point, we call it the instantaneous acceleration. It's gonna be the slope of the tangent, right? So let's get slopes of tangents. As you can see, they're all straight lines, right? So the slopes of the tangents won't matter. It'll be constant in all of them. So this is my first slope. Okay, it's a very very bad slope. بس يعني this is my second slope, or let's take it like this. This is my second slope, and then my third slope I won't have one. It's horizontal. I won't have a slope of a tangent. Okay, which is steeper? This has zero. This has zero acceleration. It's at rest. I wouldn't say it's not at rest. The velocity is constant, so there is no change in acceleration at all. There is it's zero, right? Because look, here 6 and here sorry, so at 6 seconds it's 1, and at 4 seconds it's 1. 1 minus 1 over 6 minus 4, this is 0 over 2, this is 0, right? So I have zero acceleration at this phase. Phase 3, 0, immediately ruled out. So it's between phase 1 and phase 2. Let's compare the slopes of their tangents. Now, which has a steeper tangent? This one, phase 1 or phase 2? Obviously phase 2, right? My phase 2 is going like this, but my phase 1 is going like this. Now phase 2 is way steeper, so phase 2 has the highest acceleration. Question 11. Okay, in the first leg of motion, a bicycle accelerates from rest in the positive direction at 1.5 meters squared for 6 seconds. Okay, so UARM immediately. You should train yourself. This is UARM, and this is my time, this is my acceleration. Train yourself on it. Okay, second leg of motion, the bicycle decelerates to a full stop, so it's also UARM. Now, the graph, okay, not that we need it, I'm not gonna use it this time. The graph, okay, is gonna look something like this. So V, T, it's gonna go up, then it's gonna go down. There is no like horizontal line, because there is no URM phase. It's just like this. Okay, so the magnitude of deceleration of the bicycle of the second leg of motion. So we're only concerned about the second leg of motion. We just need the deceleration, right? So we need, for the deceleration, we need to find the velocity, right? We have the final velocity, we don't have the initial. How do we find the initial? We can find it from the first phase, right? Here they told us the initial velocity at the first phase, the first leg of motion, it accelerates from rest. So what does that mean? V0 is equal to 0. We have acceleration, we have time, so 1.5 meter per second squared equals to V minus 0 over 6. Multiply 6 times 1.5 to give you V. 6 times 1.5, 9. So V here is equal to 9. Alright, now, this 9 is actually our initial velocity in the second phase of motion. Why? Look, it goes up and then it goes down. At this point, this was 9 meters per second, right? We found that from our calculation. Okay, and this is at 6 seconds, right? So then at this point, it starts switching to phase 2, right? Phase 2, and at phase 2, this was the velocity it was traveling at, and then it ended up going to rest, right? So it's gonna be 0 minus 9 over 5 seconds. Why? Because they told us the second leg is 5 seconds long, and it's you obviously know where I got V0 and VF from. So 0 minus 9 over 5 gives me negative 9 over 5, which is negative 1.8 meters per second squared. Done. Okay, now this is literally the exact same thing as question 8 or question 9 or whatever I said. Where is it? It's the same exact one. It's the same exact one, whatever it is. The one I explained about the bicycle and the arrows. It's the same concept. So I'm gonna skip it, because it's not even the same concept. It's the same answer to the same questions. So it's fine. Okay, now question 12 is very, very easy. So it looks confusing, but it's not confusing at all. The equation of velocity. Now, they want you to express it in the form of y equals mt plus b, right? It's similar to y equals mx plus b. Now, let's go back to grade 7 math really quickly. Okay, algebra 1. B, this is my y-intercept, right? This is y-intercept. This is my slope, okay? Now, obviously, y and x is when you have given an xy graph, right? But here, what do you have given? You have given a vt graph. So, v is my y and my x is equal to my t. They're the same exact thing. So, what we're actually going to write it as is v is equal to mt plus b. Now, b is my y-intercept, which I have given here, 2, right? I can find it from the graph. It's where it crosses the y-axis, 2. So, v is equal to mt plus 2, okay? Now, to find the slope, I'm going to substitute values. So, I have the point 0, 2, and I also have the point here. I have this point 4, 12. So, what am I going to do? y2 minus y1 over x2 minus x1. 12 minus 2 over 4 minus 0. This gives me 10 over 4, right? 10 over 4 is 5 over 2, which is 2.5. So m is equal to 2.5, right? So v is equal to 2.5 t plus 2. Done. Question 13. Okay, here we have a velocity time graph, and we have the speed of the car is 1 second. At 1 second is 1 meter per second squared, and a straight line to the tangent. Okay, whenever you see straight line to the tangent, immediately you should know that this is probably instantaneous acceleration. Right, and then you can find out by reading the question later. Look, instantaneous acceleration, immediately. So you already know, like you already prepare your mind for what you're about to calculate, what values you should expect to find, everything like that. Now, instantaneous acceleration at a certain point, it's gonna be let's write a instantaneous like this. It's gonna be the slope of the tangent. Okay, so right, we have this point here, and it's given to us, right? The tangent to the point, 1 second and 1 meter. It belongs to the tangent, right? It belongs to the curve, and it belongs to the tangent because it's tangential. It meets the curve only at this point, so it obviously belongs to it, right? So we have 1 comma 1, okay, and then let's look for another point. We have this point here. We have 5 comma 10. That's 5 comma 10. Yes, 5 comma 10. Now 10 minus 1 over 5 minus 1. So this gives me 9 over 4, which is 9 over 4, 2.25. Yes, 2.25 meter per second squared. That's the end of the answer. Okay, question 14. Okay, now for this question, we have the VT graph, okay? They want us to find, first of all, when the particle is instantaneously at rest. Now, what does that mean? What does it mean to have a particle instantaneously at rest? It means, okay, when obviously the displacement is 0, right? Or sorry, not displacement. What did I say? Displacement. Velocity is 0, right? Because when its velocity is 0, that means it's not moving, right? So there is no motion, which means aka at rest. When is velocity at 0? When it crosses the x-axis, or sorry, crosses the t-axis, let's say, on a VT graph, right? So it crosses here and here. Now this point here is 8 seconds, and this point here is 13 seconds, and those are your 2 points. The instantaneous acceleration of the particle at t equals 5 seconds. Okay, instantaneous acceleration of a particle at t equals 5 seconds. So here, t equals 5 seconds here, and they're so generous as to give us the tangent, right? They told us the points of the tangent, so we don't even need to do anything. We don't even need to look at the graph. So we have 1,7 and we have 12,0, right? So we're gonna do, I'm gonna take this point as my 2, y2, x2, x2, y2, whatever. So 0 minus 7 and 12 minus 1. This gives me negative 7 over 11. So negative 7 over 11 gives me negative 0.63 meters per second squared. Now I want to see what they have it as. They have it as negative 0.6. Yeah, you round down, so it's fair. It's an accurate answer. A skateboarder is moving along a horizontal path with velocity of 2 meters per second. The skateboarder pushes off with their foot, and 5 seconds later, the skateboarder's velocity becomes 12 meters per second. Now, the average acceleration, okay, you have V initial, you have V final. This should be very, very easy. So 12 minus 2 over 5. This is 10 over 5. What's 10 over 5? 2 meters per second squared. Done. Okay, question 16. Okay, for this one, the acceleration of the particle at equals 1.45 seconds. So we have the tangent here. We have this point here. And we have, I need to zoom in. This is not very nice. So I'll even see my axis. So I have this point, and I have, actually they have another point given for me, no? Like, they give me the points. The velocity time graph is okay. So it's tangent to a very, very small point. Wait, I think I can make out something. Okay, I think this point belongs. So, what are these 2 points? Let me go down here. Okay, so this point here and this point here. Okay, so actually I wouldn't really like that. This point here is better. Okay, so for this you have these two. Actually, let me not do that. I can take an approximation, and I'm assuming it will be approximate enough if I take these 2 points. It's close enough. So you can do this, but I wouldn't trust it. I wouldn't rely on it. So 1.2 minus 1. Okay, this is for my x, right? This is x2, x1, right? And then I have 1.2 minus 1. So my acceleration, my approximation of the acceleration is 1 meter per second, right? Oh wait, it's negative 1 meter per second, right? Because it's going down and I didn't account for that, yes. So it is negative 1 meter per second, yes. I didn't see the negative sign on my calculator. My approximation to my acceleration, why did I go into Google Messages? My approximation to the acceleration I got using the approximation I used this, this here. Why is my pen not writing? Okay, I don't know why it's lagging so much. I used, oh my god. I used this here and I used this here, right? Now, approximating, this will give you an approximate value of negative 1 meter per second squared, right? Now, negative 1 meter per second squared, the answer is negative 0.9. So it's obviously reasonably close enough. And I'm telling you, it's not 0.9 exactly. It's probably 0.9 something to the way they had to round down. So it's even a closer value, right? So you can take it as this and round down. But in the exam, I'm telling you, they will not give you an axis this small because the computer screens are terrible, at least in my school. So it'll be very, very hard to see the axis points. It'll be very, very hard. So for the graph now, I just approximated. طبعا, you shouldn't do this. You genuinely should not do this in an exam, especially if it's a typing question. Multiple choice, if the answer is close enough, you can probably get away with it, right? Because, like, for example, here I got negative 1, right? The actual answer was negative 0.9, which is close enough. So it's fine, right? I can get away with it. I round up to it anyway. So it's fine. But if it's a typing question, you should not risk it like that, first of all. And even if it's a multiple choice and your answer is far away from like a roundable answer, then you did something wrong. Either that or you should use the exact values and an approximation will not work out for you. So don't do what I did. I just did it as a shortcut because I genuinely can't see the scales. Like, it's very, very small for me. Like, maybe this point here. Maybe this point here. This is a point. This is an actual valid point. But look, like, the line is almost invisible. So it's, it's fine enough for me to take an approximation. Okay, question 17 is very easy. So they want us to find the displacement of this object. Now, displacement, again, is the area under the graph. So what we're going to break it into, we're going to break it into this part here. What is wrong with my pen? It's like very laggy. 1 second. Yeah, I mean, okay, whatever. So, yeah, my pen is actually very, very laggy. Like, it's not, yeah, it's very far off. Wow. Okay, I don't know what's going on. I'll fix this later. But for now, we're gonna break this into a triangle. Okay, what is going on genuinely? Okay, so we're gonna break this into a triangle, and we're gonna break the second part into a trapezoid. So we're gonna have this part. Okay, this part's fine. It's here. It's just this region. Or wait, does it work now? Samsung Notes, thank you. Ignore these technical difficulties. I don't know why they happen to me and me only. Okay, خلاص, just take it like this. We have a triangle here. Okay, and then we have a trapezoid here. So let's find the area of the triangle. Half times base. The base is from 0 to 4. So half times base times height. What's wrong? 6. So this will be 12. Right? For this part, it's 12. Okay, now for this part, okay, it's a trapezoid. So, or you can actually break it into a triangle, a rectangle, and another triangle. But who is actually doing that? So, base 1 is from 4 to approximately 12, right? It doesn't go fully, but it's fine. So it's gonna be base 1 is from 8 minus base 2 is from about 8 to 10, so 2, right? It's from this point here, which is 8 and 10. So 8 minus 10, 10 minus 8 is 2 over 2 times the height, which goes from 0 to negative 6. So our height is actually 6, right? But it's the displacement, so we're gonna do negative 6. Now, thank you. What are you opening? What are you even opening anymore? 8 plus 2 over 2 is 5, right? Because 8 plus 2 is 10. 10 over 2 is 5. 5 times negative 6 is negative 30. Now, we have 12. 12 minus 30. 12 minus 30. Negative 18 meters. Now, this isn't going to be the exact answer. No, it is the exact answer. It is negative 18 meters. So, خلاص, we're good. Okay, question 18. A block initially moving at 20 meters per second is decelerating at a constant rate. So, what's the displacement? Okay, here UARM, immediately UARM. So, x is equal to half AT squared plus V0t. Actually, you don't have t. Okay, you're going to use the time independent equation. V squared minus U squared equals 2A delta x. Okay, so V squared is for, we don't have it. Okay, this is, no wait, we do have time. Why didn't I read that? I didn't see that. This is V0, right? We don't have V final. We have A and we have T. My bad, I did not read. Okay, so x is equal to half AT squared plus V0t plus x0. Okay, so the displacement means you take x0 to the other side, so that means delta x is equal to half AT squared plus V0t, right? So delta x is equal to half times A is 4 times t squared, t is 6, so times 36 plus V0 is 20 times 6. Do this on your calculator. So 0.5 times 4 times 36 plus 20 times 6 gives you 192. Wait, what? Oh, what did I do here? 1 second. Initially move. Oh, negative 4. This is negative 4. Not that I think this will make a big difference, but it's fine. 0.5 times negative 4 times 36 plus 20 times 6. Now it gives me 48. This is negative 4. Okay, this means since it's decelerating, negative acceleration, that means A is equal to negative 4. See, this is why you read the question. This is 48 meters. Right? Decelerating. Okay. Question 20 or question 19. Sorry, I'm getting out of myself. A car initially moving at 30 meters per second decelerates to 5 meters per second in 3.8 seconds. What is the acceleration? Acceleration, okay, is gonna be 5 minus, look, this is V final, this is V initial, right? 5 minus 30 over 3.8. So do this on a calculator. 5 minus 30 over 3.8. Negative 6.57, we're gonna round to negative 6.6 meters per second squared. That's the answer. Question 20. Okay, this question is honestly common sense, right? It's a straight line. And remember what I said at the start of the video, straight line, UARM. UARM, constant acceleration. Constant acceleration means the instantaneous, I said this even in the start, the instantaneous and the average are the same acceleration, right? Because the instantaneous is the slope, right? When you derive the equation of this, you're gonna have the slope, right? When you derive mx plus b, right? dy by dx, you get m. Right? You're gonna get m. M is the slope of the graph, right? So that means at a certain point, at any point on this graph, the acceleration is gonna stay the same. So all I have to do is find the average acceleration, and at UA or M, the average acceleration is the same thing as the instantaneous acceleration. Just know it. On the graph, it's a straight line, so average is the same thing as instantaneous. It's common sense, but just in case. Okay? So you have 1, 1 as a point, and you have 3, 0 or 0, 3, right? So 3 minus 1. We're gonna do 3 minus 1 over 0 minus 1. Gives me negative 2 meters per second squared. However, the answer is 2. Why? Because they said magnitude. Magnitude means you only write the number, not the sign. So it's 2 meters per second squared. Question 21. Okay, question 21. Total displacement of the cyclist. Okay, now the displacement, as you know, is the area under the graph. So what are we gonna do? We're gonna divide it into two triangles. So we're gonna divide it here, and we're gonna divide it here. Okay, now it's the area under the graph. So you have 0 here, and then you have 6. So half times base times height. So half times the base is 20 times the height, which is 6, right? This is for the first one. Now, so the second triangle is half times the base. The base is from 20 to 80. What's 80 minus 20? 60. Times the height, which is still 6. So, do this on a calculator. 0.5 times 20 times 6 plus 0.5 times 60 times 6. This gives you 240 meters, and that is your answer. Question 22. Okay, a runner passes the start line at a speed of 1 meter per second and decelerates at a rate of 0.50 meter per second for 10 seconds. The displacement. Okay, displacement. Here, you're gonna use half at squared plus v0t. Okay, the displacement, delta x. There is no x0 because you took it to the other side, so you have delta x. Delta x is equal to half times a, which is 0.5, times t squared, which is 10. 10 is t, so 10 squared is 100. I'm doing it directly. Plus v0. v0 is 1. And then t is 10. So this is going to be half times half, which is 0.25, times 100 plus 10. 35 meters. Done. Okay, question 22. Or question 23, sorry. So they want instantaneous acceleration. You have tangent, you have this, blah blah blah. So you have the point 10,5, and you have the point 40,15. So you're gonna do 15 minus 5 over 40 minus 10. Gives you 0.33, and that is your answer. Okay, question 24. In order to extract blah blah blah, based on the student's data, what's the value of the free fall acceleration? You have meter, and then you have second. You have xt, right? You have xt graph. Now here, what you're actually gonna do is, I've actually didn't do this quiz before, so I'm actually just gonna take an approach. I have, what points do I have? I have this point that they marked. Sure, I'll mark it here. Okay, that's fine. And then I have apparently this point that they also marked. But I don't want to find the axis behind these. Okay, I'll take this point instead actually. Okay, so we have 0.2, comma, what on earth are you? Okay, this is a very confusing question. 1 second, I'll come back with the point. Okay, so these are my points, right? Now, you find the slope between the two. 0.9 minus 0 over 0.2 over 0 minus 0, sorry. This gives you 4.54, okay? Now, you might notice that's the slope, right? But however, this is based on the formula h is equal to half gt squared, right? So they graphed this, they took this, let's say this is m, like m is as in the slope. So h is my y-axis and t is my x-axis, right? So it's h is equal to mt squared. M is my slope. What is m equal to? M is equal to half g, right? And I just found m is 4.5, right? M is equal to 4.5. So 4.5 is equal to half g. Now, that means g is equal to 2m. So you multiply your answer by 2, right? So 9 over 2 times 2, which is going to give me 9, right? Because 4.5 is 9 over 2. So 4.54. Or actually, wait, no, I got 4.5 exactly. Where did I get 4.54 from? 4.5 exactly, right? So multiply it by 2, you get g is equal to 9 meters per second squared. Done. That's my answer. And as you can see, that's what he obtained. Question 25, which is the last question. And this is the easiest question I've ever seen on the face of the earth. What is the following is the gravitational acceleration near the surface of the earth? You should know, you've been using it for every calculation in the past. God knows how many questions. 9.81 meters per second squared. You're done. Good luck, guys. Have a good day.